Okay, so we have x-intercept as infinity a, y-intercept as 1b, z-intercept as infinity c. So then we have to express this in terms of ABC. When we express this in terms of ABC, what we get is this one. We get infinity a by a. This is 1b by b. This is infinity c by c. Okay, then we have to take the reciprocal of these values. When you take reciprocal of these values, what we get is 1 over infinity. We are eliminating a and b in this step. That's it. Nothing much. It is a procedure which is being 1 divided by 1. This we get 1 divided by infinity. So this is set of 3 values. Okay. So here we have to again further reduce this. You get this is equal to 0. This is equal to 1. This is equal to again 0. So we end up with 0, 1, 0. This is our HKL value for this plane. Clear?
Yes, sir.
Here, any doubt?
No, sir.
3 simple steps. That's it. 3 simple steps. That's it. Nothing more. Okay. Done. Do you have any doubt here?
Yes, sir.
Yes. What is the doubt?
How did you get in the first figure 101, sir? I didn't get clarity to find that coordinate, sir.
Okay, fine. Simple. Here, this is the plane, right? So this plane is like this. It is not just this one. It continues, right? This direction also it continues. Okay. Where do we see it meeting or intercepting x-axis? It is intercepting x-axis at 1a. It is also intercepting z-axis at 1b. But it stays like this. Okay. It never intercepts y-axis. Clear? Yes or no?
Yes, sir.
Yes or no? Yes, no? So it intercepts x-axis at
Yes.
1a, y-axis at 1c. It intercepts, x-axis at 1a, z-axis at 1c. It never intercepts y-axis. So y-intercept is infinity. You
Okay,
take
sir.
the reciprocal of that, reduce it, you get 1, 0, 1. Clear?
Yes, sir.
Clear?
Yes, sir.
Okay.
Yes,
This
sir.
one, you know. This one, similar. Just the orientation is different. That's it.
Yeah, we got this, sir.
Okay, fine then. This one is also clear.
Yes, sir.
Good.
Yes.
Is this clear?
Sir, explain this one.
Yes, sir.
Yes.
Explain this, sir.
Here the first one, it is not a problem. This is straightforward. No problem. You can fix this point as origin. In the second one, you have a problem. If you fix this as origin, it is passing through origin. So you have to shift the origin. Either you have to shift the origin to this point or this point. You don't have any other option. Okay. Just let me remove this. Just give me a minute. Give me. So here, problem is with this one. With this diagram. Problem is with this diagram. Okay. Here if we fix this point as origin, then suddenly we are going to find the HKL value in terms of infinity. Okay. Right? Because it cuts or intercepts x-axis and z-axis at 0, 0. So when we take the reciprocal, somebody's microphone is unmute and it's causing noise. So if we take this, we'll end up with infinity as HKL values. That is not possible. So here, such things you have to be careful. Okay, if the origin is not mentioned, if it is mentioned also, you have to be careful. Here you have to shift the origin so that it can be here or at this point also. If the origin is here, okay, this direction, let's call it as X or Y. This direction, shall we call it as X or Y? What shall we call?
It's X,
Y.
sir.
X. In the previous diagram, it was Y. Here we'll take it as X. So this we'll call as Y. Okay. So this particular plane cuts or intercepts X.
Sir, is it our
at
choice,
1A.
sir, to choose
Yes, your
X and
choice,
Y?
but you have to be clear. In the diagram, you have to be clear. You have to mention it. That's it. So based on that, your HKL values changes. That doesn't matter. But you have to mention the coordinate system properly. There is no rule that you have to take this as X and this as Y. You can change it. In fact, some people take this as Z and this as Y. But you have to be very, very specific in your representation. Okay. So this cuts x-axis at 1A and this cuts y-axis at minus 1B. This is positive y-axis, this is negative y-axis, minus 1B. And it never cuts z-axis. It is always parallel to z-axis. So we get x-axis intercept 1, y-axis intercept minus 1, z-axis intercept infinity. In terms of ABC, I have eliminated ABC. Now take the reciprocal, you get 1, minus 1 and 0. Minus 1 is represented with a bar over it and this is HK. Right. If we take this as the origin, let's say, if we take this as the origin, this is positive x-axis. Okay. This is z-axis. This is y-axis. Okay. In this case, it cuts x-axis at minus 1, y-axis at plus 1, that is 1b, z-axis at infinity. So take the reciprocal and represent it. When you take the reciprocal, this becomes minus 1, this becomes 1, this becomes 0. That's it. So this is, if you take this as origin, this one, this one, if you take this as origin. Okay, here. Any doubt?
No, sir.
No, sir.
No, sir.
Next, this one again, this is generally we take this as origin, but again it has the plane is passing through this point itself, so we'll have to shift the origin. We cannot shift this side because plane is there again, so we'll have to shift it this direction. Okay, either this one or this one. These are the two options generally we take. Okay, either this one or this one. You can even take this one, doesn't matter. So if we take this, it is minus 1. Okay, it never cuts x-axis. If this is x-axis, this is y-axis, and this is z-axis. Okay,
Can
so we
we take
get
right side bottom? Point, right side bottom.
this one, This one?
No, sir. Front one, sir.
This one you can take.
Yes, sir. Okay.
You can take this one. In that case, y becomes, see, whether you take here or here, it doesn't matter. See, -1 here, -1 here, y. Z is +1, Z is +1. It doesn't matter whether you take here or here, because crystals have symmetry. Okay. Only thing is you have to shift from this point. That's it. You have to shift from this point, not along x-axis, either along y-axis or along z-axis. If you take along y-axis, you get y is at -1, z is at +1. Okay. So you get x-axis is 0, y is 1 bar, z is 1. You can even take this one. You can even take this one. If you take this one, y becomes, if you take this one, this is y, this is z. Okay. And this is x. It cuts y-axis at 1b, z-axis at, come on, quickly.
1 bar minus the x negative.
-1. Very good. So in that case, y becomes positive value, z becomes negative value. That's it. Too simple.
Sir, in examination point, we have to draw the diagram. They give the point.
See, they may ask you to just see. They will ask like, you draw 1, 4, 6 plane. Draw 1, 4, 6 plane. What do you have to do first? This is h-scale values.
Take reciprocal of that.
Yes, take reciprocal and find the intercept. This represents x-intercept. This represents y-intercept. This represents z-intercept. Okay. Once it is done, you mark 3 points. Mark 3 points and then represent a plane. Let's see how it works. We'll take 1 or 2 examples and see. Okay. Give a minute. I'll give you some. Or we'll do it later, no? One class instead of now. Now we'll continue the class. Okay.
Yes.
Don't worry. We'll solve.
Sir, will you tell that tomorrow, sir?
Yeah. Tomorrow we'll solve some problems. Tomorrow, tomorrow only we can do. Okay.
Yes.
Right now we'll solve some problems tomorrow. So now let's moving on to. This is interplanar spacing. See, we discussed that a crystal can be represented with a set of planes. Right? There are 3 ways to represent a crystal or build a crystal structure. We know that. Translation of unit vectors or basis vectors. Then take a unit cell, extend that unit cell, or go on repeating that unit cell. Or else you take planes, parallel planes, and go on stacking them by maintaining certain required distance. Okay. So these are the 3 different ways you can build
Lattice.
Yeah, lattice, crystal lattice. Now we have these planes. These are the parallel planes. This is a cubic lattice structure which can be formed in many different ways. So this is one set of planes, right? 1, 0, 0 planes. You know 1, 0, 0 planes? This is another set of planes, 1, 1, 0 planes. This is 2, 0, 0 planes. 2, 0, 0 planes. What is this 2, 0, 0 planes? What is the intercept? Can you just guess?
2a.
2 on the x.
1 by 2, sir. 1 by 2, sir.
1 by 2, infinity. That
Yeah,
means
1 by 2 infinity.
here, very good. Here, if we take this point, no, this point, it represents 2, 0, 0 plane. Very good. This represents 2, 0, 0 plane. This comes into help when we have this body-centered atom. or body centered cubic structure. Okay. So here, this is 2, 0, 0 plane. This is 1, 1, 1 planes. 1, 1. So you can represent a crystal structure using these different types of planes. Now, what we need to know is, when we represent like this 1, 0, 0 planes, this is the distance between the planes. We have to maintain this distance. When we represent using this, we have to maintain this distance. That is called interplanar distance. When we represent using 2, 0, 0 planes, this is the distance between planes. When you represent 1, 1, 1 planes, this is the distance between planes. So when we know different planes, 1, 0, 0, we know very good, fine. But we take one plane, where to keep the next plane? We should know the distance. Where to keep the third? Where to keep? To do that, know the spacing between them, right? All that we have is these HKL values, 100 or 111 or 200. All these are called HKL values. Can we represent the interplanar spacing in terms of HKL values? Of course, yes. If we know HKL and the lattice parameter, if we know HKL values and lattice parameter, we can represent interplanar distance. That means you choose any plane you want. We can very easily say, substitute a lattice parameter and HKL value of that plane. We can say, see, this is the distance between two adjacent planes. So it is very easy for us to construct a crystal structure, right? So for that,
Sir, in this
let's
planes,
start.
what did you took the origin, sir?
Sorry?
In these planes, what did you took the origin, sir?
You don't have to worry about the origin now. Just the distance between two planes, that's it. Wherever they are parallel planes, no? Wherever you measure, it is same. A perpendicular line between these two planes gives the same value wherever you measure.
Sir, but with what reference you are taking this as 110, 100 planes, sir?
See, I tell you, 100 plane. See here. Wait a minute. See here. This one is 100 plane if it is x-axis. Okay. This is y-axis. This is 010 plane. This is z-axis. So this is 001 plane. So in a cube, if there is a cube, any plane which is like this, parallel planes, they are all called as 100 plane. You don't need an origin. You fix any origin, that is what you get. This plane. This plane is also called 100 plane. This plane is also called 100 plane. This plane is also, next plane is also called 100 plane. Like this you get. Next you get one more plane. All these are called 100 planes. You don't have to worry about the origin. You want to define this plane, fix origin here. You want to define this plane, fix origin here. You want to define this plane, fix origin here. They're all same, right? They are called parallel planes. So they're all called as 100 planes. Any doubt?
Then what about 110, all those like that, sir?
Well, exactly. They are also same. This is this one actually. 1 minus 1, 1 bar 0, right? This one is 1 bar 0, right? Here you get 1, then again you get 1 over here. Okay, then you get again 1 over here. They're all same. They're all parallel planes. You define one plane, anything parallel to all these planes are represented by the same name. You don't need different name. If this is 1 bar 0 plane, okay, this as is 1 bar 0, this is also 1 bar 0. If you go further to any distance in the same direction, you will always get 1 bar 0. This is the normal to this what is this plane. This is the normal. So you move in this direction and go on checking the planes perpendicular to this normal or this line, you always get 1 bar 0 plane.
Sir.
Yes.
Sir, but here we can represent it as with respect to that last point, we can represent minus 1 and 0 plane also, na?
It doesn't matter whether you represent it that way or this way, doesn't matter. Either with respect to this, you can represent it as 1 bar 1 0, right?
Yeah.
So 1 bar 1 0 and 1 bar 0 doesn't differentiate at all. They always look same. Okay, that is why look here. Here, this plane which is called as 1 0 0, this plane, the yellow plane, okay, yellow lines plane which called as 0 1 0, and this plane perpendicular to z-axis which is called as 0 0 1 plane. Okay, so we have here 3 planes. Let me write it. 3 planes, 1 0 0, which is perpendicular to x-axis. Then we have 0 1 0 perpendicular to y-axis. Then we have 0 0 1 perpendicular to z-axis. Okay, and then we have 1 bar 0 0. Okay, then we have 0 1 bar 0. 1 bar 0 0 means instead of this point as origin, you take this point as origin and characterize this particular. Just a minute. Let me just a minute. I want to discuss this once more. Just that's a good question. Let me come to you. Okay, so now let's consider this as origin. Let's take this as one plane. So this is 1 0 0 plane, considering regular x y z axis. This is x, y.
Sir,
Just a minute. Yes, z axis. Okay.
sir, once you take y-axis horizontally and show, sir, please.
I didn't get.
Sir, actually now you took x-axis there, right, sir? Hello, sir.
Yes, yes, sir.
Sir, now x-axis is taken horizontally, right, sir? Once that place y-axis and show the orientation, please, sir.
Doesn't change anything.
Okay.
I'll do it. Just a minute. I'll do that. That's not an issue. Oh, this you wanted y. Okay. So in that case, this becomes
0 1 0.
Yes, that's it. Nothing much. This becomes 0 1 0. Okay. So this becomes 1 0 0. And the top one becomes, this one becomes 0 0 1. Okay. Thing is, hey guys, listen here. This x y I changed, right? Right? Somebody wished x. I have taken x here, but one of your classmates wished I want y here. I changed. There is no question. Similarly, I've taken Z here, none of you questioned, but if I want, I will take this as X, this as Z, this as Y. Okay, and somebody may want to take this as Z, this as X, this as Y. We cannot question, right? We cannot question. All these in our lower classes, we have taken this as X and Y, but now we take this as Z. Some people take this as Z. So here what I want to say is the X, Y, Z perception, it all depends on our convenience and how we choose an origin and its direction. That's it. So when I say that this 0, 0, 1, 0, 1, 0, or 1, 0, 0, or in other words, when I say that this plane, right, this plane and this plane and this plane, we cannot differentiate between them just because they lie at different directions. Do you agree or not? If we interchange X, Y, Z as our will and wish, we can always go on designating these planes with different HKL values. The plane which is 1, 0, 0 here can take 0, 1, 0 or can also take 0, 0, 1. Do you agree?
Yes, sir.
Similarly, let me tell you. Similarly, this plane which is 0, 1, 0, we have taken this as origin. I can extend this and I can take origin here. I can take origin here. When I take the origin here, what happens to this plane? This plane?
Minus 1 y.
It becomes 0, minus 1, 0, right? Okay. Yes or no?
Yes, sir.
Yes, sir.
Similarly, I
Yes,
can
sir.
take origin here. When I take here, what happens to this?
1 bar 0.
1 bar 0, 0. So, just because they are lying at different directions, we cannot differentiate between these planes, right? So these planes, let me write 1, 0, 0. Okay, 0, 1, 0. 0, 0, 1. They are different just because we have chosen our coordinate system like that. But if we change our coordinate system, they become interchangeable. Similarly, 1 bar 0, 0, 0, 1 bar 0, 0, 0, 1 bar. What is the difference between 1, 0, 0 and 1 bar 0, 0? Just the point selection of the origin. If you move the point by 1A, you will get 1, 1, 0, 0 will shift to 1 bar 0, 0. Nothing else. Yes or no? Right?
Yes,
This
sir.
is the plane.
Yes,
Sir.
sir.
You take
By
this as
2A, no,
origin,
sir.
it becomes
By
1A.
2A, no, sir.
Okay. Sorry, 2A. Okay. If you shift the origin to here, this becomes minus 1. So, considering that all these planes are equivalent. All these planes are equivalent. When I say 1, 0, 0, it represents all the other 5 planes. Right? So 1, 0, 0 is always used to represent all the planes, and this is called as family of planes. Family of planes, and it is represented as 1, 0, 0 with a flower bracket. So when we see something like this 1, 0, 0 in a flower bracket, this represents 1, 0, 0, 0, 1, 0, 0, 0, 1, 1 bar 0, 0, 0, 1 bar 0, 0, 0, 1 bar. All these are represented by just one particular plane. Okay, clear? Okay, move on to Right, check who is that microphone is on. Which of that? Mute your microphone. Gaurisha, where are you, man? Fine. So these are the parallel planes. We can represent crystal lattice with parallel planes. So if we have to represent crystal lattice with parallel planes, we need to know the distance between the individual planes. Can we represent this distance between the individual planes, the particular set of planes with value, that is in terms of HKL and lattice parameters? Let's see that. So this is a 1-1-1 plane. Just this is x-axis, y-axis, z-axis. We have taken z-axis cut at 1, y-axis cut at 1, x-axis cut at 1, and we have got 1-1-1 plane. Let me tell you. Just a minute. I'll have to take that one. Okay. So this one, same diagram is used there. X-axis cut at 1, y-axis cut at 1, z-axis cut at 1. So this is 1-1-1 plane. Okay. Clear? Now imagine one more plane, where imagine one more plane exactly at the origin. That means that plane is from the next unit cell that is touching this origin, that is passing through this origin. That is from the unit cell which is below. Okay, that will be passing through this origin, and it is parallel to this plane. Can you imagine?
Yes, sir.
Okay, all of you have to imagine. You don't have an option. Okay, imagine one more plane. One more plane. See, this is one plane, right? Okay, you have to imagine one more plane, where you have to imagine one more plane passing through the origin. Passing through the origin. Right? Origin of this unit cell. Passing through origin of this unit cell. See, these two planes are parallel to each other. These two planes are parallel to each other. Right. If we find the distance of this plane, the shaded plane from the origin, what does that give?
1.
If we find the distance of this plane, the shaded plane from the origin, what does that give?
Interplanar distance.
Yes, that's distance between two planes. Distance between two planes. Which are those two planes? One is a shaded plane, shaded area. What is where is the other plane? Other plane is the origin, and other plane is passing through the origin and parallel to this. So we have to just find the distance of this plane, the shaded plane from the origin. We get the distance between these two planes. Right? Fine. Now, see what I have taken is, this is one plane, which is 1-1-1 plane, which cuts x-axis at 1, y-axis at 1, z-axis at 1. Another is the plane which is parallel to this, placed at the origin or passing through the origin. Okay. Now, I draw a line OP perpendicular to this plane. I can draw OP perpendicular to this plane. I drop this OP onto the plane. This OP is perpendicular to plane. Clear? Can you imagine?
Yes, sir.
Yes, sir.
Now what I do?
Sir,
from
for
this
what
point,
the OP is perpendicular, sir?
For the plane. For the plane, OP is perpendicular. Okay.
Yes, sir.
It has to be
Sir, can you
perpendicular.
please explain it once, sir? Getting confused.
Draw a line OP onto the plane. Okay. Draw a line OP onto the plane.
Yes, sir.
Okay. Perpendicular.
Yes, sir. Okay, sir. Yeah.
Now, from that point P, you drop a line onto y-axis at 1A, 1B. Y-axis at 1B. That means at point where the plane is intercepting y. Drop a line onto y-axis at the point where P is intersecting. Now, this line is running on the plane. This line PB is running on the plane. And it meets the y-axis at B, where the plane is cutting. It is just running on the plane and meets B at y-axis. Sorry, meets y-axis at B. Okay.
Yes, sir.
So the OP is centered.
Now we have.
So the OP
Now
is
we have a
perpendicular to the
triangle.
center, no, sir.
OP is
Perpendicular to the center of the plane, no, sir.
yes.
Okay, sir.
And you are running a line. You are running a line from P to B on the over the plane, exactly on the plane. Therefore, this angle at P between OP and PB, that is
90 degrees.
very good. The angle between OP and PB at the plane is 90 degrees. Okay, and then the triangle OPB. This is the triangle. Okay, OPBO. This is the triangle. So in this triangle forms right angle triangle. Right angle is at P. Okay, and the angle that this P makes with y-axis is called theta 2. Here it is written as beta. In your diagram, you write it as theta 2 because I don't want you to get confused between the angles alpha, beta, gamma, what we had used previously to define basis vectors or crystal lattice, and with this. So you write down the angle OP, OP makes with y-axis is theta 2. Right. So this OP, so from P, we also draw a line on x-axis. That is PC. So OPC, this also forms a right angle triangle. Okay. And the angle OP makes with x-axis is theta 1. Angle OP makes with x-axis is theta 1. Similarly, from P, we also drop a line on z-axis. That is PA from P. So triangle OPA again becomes right angle triangle. Triangle OPA again becomes right angle triangle. The angle that P makes with z-axis is theta 3. Angle P OP makes with z-axis is theta 3. Here it is written as gamma dash. You write it as theta 3. So what we see here, we have three right angle triangles, right? OPB, OPC, OPA. Three right angle triangles, and OP is common adjacent to all the three. Do you agree? OP is common adjacent to all the three. So we can represent OP as the distance between two planes. One plane that is at the origin and the plane what we have taken. It is the angle between two planes. We represent it as DHKL, X cos theta 1, Y cos theta 2, cos theta 3. Do you agree? Any doubt?
Sir?
Yes. Don't worry.
Sir?
Don't hesitate. If you don't understand, let me tell you. Yeah.
Sir, can you name the plane there? Is it A, P, C, A?
Plane is ABC. This is the plane. Let me tell you. This is the plane. From A to C, from C to B, B to A. This is the plane. It is in the shape of a triangle. Okay. This
Okay,
P
sir,
is
then
a point. P is a point on the plane. Okay.
So we have to imagine a 3D
Which
picture.
connects O. Which connects O. So this O and P is perpendicular to the plane.
yes, sir.
This OP is a line which is perpendicular to the plane. Because what we are trying to find here is distance between two planes. One is this plane, another is a plane which is at origin. Right? How to find the minimum distance between any two parallel planes? The distance, the line has to be
Perpendicular.
perpendicular. That is why OP is perpendicular. Or OP is 90 degree at P. Clear?
Yes, sir. Thank you.
This
Sir,
one.
so the distance between two planes
Wait,
now is OP, right, sir?
Yes, exactly. So this distance, sorry, this angle, you write it 1. Okay. And this angle, you write it as theta 2. And this angle, you write it as theta 3. Guys, time up. You want to continue or shall I close? You can continue tomorrow. I don't want to eat your break time. Okay?
Sir,
Yes.
so many of us joined EC from Tripoli after. Can you please share the previous lecture videos recording?
See, unfortunately, I don't have access. I have requested the class advisor or the person who has organized this meeting, Mr. Satish Kumar, to share. Okay. Unfortunately, he has to share all the recordings because he is the RA organizer. He would have recordings of all the classes, not just my physics class. Right?
Okay.
So
Okay,
his problem is again, but that his problem is way more than what we think. So okay. So today I'll again contact him. Let him download all the recordings of all the subjects and share it. Okay.
Okay, sir. Thank you.
Okay. Give me some time. Thank you. Thank you very much.
Sir, there
Let's
is
meet
no
tomorrow
plane
at
at origin, no, sir.
There is one plane. You have to imagine.
Oh, okay, sir.
It is there. It is from the. It is 111 plane of the. It is 111 plane of the unit cell which is below. See.
Oh, sir. Also, we will again briefly explain this concept tomorrow, sir. Interplaning spacing.
Yeah. Okay. I'll do that. That's better. Okay.
OP is the distance between which two planes?
I'll tell you tomorrow. Tomorrow let's discuss. Okay.
Okay.
Tomorrow let's.
Thank you, sir.
Fine then. Take care, guys. Bye.
Thank you, sir.
Thank you.